Okay, this is going to be a really quick video on how to calculate the percent error. The method used here will work for any lab, but we're doing this in reference to a lab that we've been working on related to acceleration due to gravity. For the lab, here's our data to this point, and we used this value right here, negative 4.9677, as the x squared or the t squared coefficient. We recognize that for the position and time relationship that's 1/2 of the acceleration, so we doubled it down here to come up with the actual acceleration value as predicted by this experimental data that you can watch in previous videos to see how we got. Now let's just write that down. That's 9.9354 meters per second squared, and it was negative. I just didn't include the negative when I doubled it. So what we have here is we have our measured value from an experiment. We need an accepted value for acceleration due to gravity as well. Acceleration due to gravity in the we're going to assume is pretty close to negative 9.8 meters per second squared in the school where I'm doing this. So we have that accepted value. So now we can, I'm going to call that measure, and I'll call that theoretical. Now I can do the percent error. Percent error is equal to the measured value minus the theoretical value divided by the theoretical value. Some people will put this, times 100% if you like to see that. I don't always write it, but it's there if you want it. Some people will put that in absolute values if you want. If you're only interested in how far away you are from what's accepted, then the absolute value makes sense to me. But since we want to know whether or not our value is a little too high or a little too low, I'm going to leave them off. So I got negative 9.9354 minus negative 9.8 divided by negative 9.8, and I'm going to get a value of 0.1354 on the top, that's still a negative, and negative 9.8 on the bottom, and so a value of 0.0138. I think when we look at this value, you can see why people don't really like it as just a straight number, because 0.0138 isn't really something that I think sits well with us in terms of just interpreting it. Something that looks a lot nicer as a percent, and in this particular case we have 1.38% error. Now we'll notice here that the sign turned out to be a positive, and I did not absolute value at the beginning. So that positive sign tells you that my measured value was slightly larger than the value accepted, as we've taken it as negative 9.8 meters per second squared. So that's how you do a percent error calculation.